Next problem. Find the Fourier series of f of x equal to square root of 1 minus cos x. Square root of 1 minus cos x in interval 0 to 2 pi. 0 to 2 pi. Hence evaluate 1 over 1 into 3 plus 1 over 3 into 5, 1 over 5 into 7, and so on. And so on. Solution. Solution. F of x equal to square root of 1 minus cosine x. Square root of 1 minus cosine x. So I can write this one as 1 minus cosine x is nothing but 2 sine square x by 2. So under root 2 sine x by 2. Sine x by 2. What is the Fourier series formula? Fourier series of f of x is f of x equal to a naught over 2 plus summation n equal to 1 to infinity an cos nx plus summation bn sin nx. N is from 1 to infinity, equation 1. And what is a naught formula? Where the first quotient a naught equal to interval is 0 to 2 pi, so 1 over pi 0 to 2 pi f of x dx. That is 1 over pi integral 0 to 2 pi. This is root 2 into sine x by 2 dx. Sine x by 2 dx. This is equal to root 2 by pi. What is sine x by 2 integration? Minus cos x by 2 whole by 1 by 2. This is between the limits 0 to 2 pi. Between the limits 0 to 2 pi. Okay. This is equal to this minus and this 2 root 2 and minus by pi. Yes. And what is this? Cos x by 2 in the interval 0 to 2 pi. Just a minute. Next one, 0 to 2 pi. So substituting the limits, minus 2 root 2 by pi. This is upper limit first. Cos in place of x 2 pi. In place of x 2 pi. So cos pi you will get minus cos 0 1. Minus 2 root 2 by pi. What is cos pi value? Minus 1. Cos pi value minus 1 minus 1 minus 2. So finally 4 root 2 by pi. A naught value is 4 root 2 by pi. A naught is over. Now coming to an. All are joined? Yes. Okay. Now an formula 1 over pi integral 0 to 2 pi f of x into cos nx dx. This equal to root 2 outside 0 to 2 pi. F of x is, what is f of x? Root 2 into sine x by 2. Root 2 into sine x by root 2 outside. So sine x by 2 into cos nx dx. Cos nx dx. Now here this is multiply divided by 2. This is a value 1 by 2. Sin a cos b. A value x by 2 and b value nx. So multiply divided by 2. But I'm getting root 2 by 2 pi integral 0 to 2 pi 2 sin a cos b dx. Cos b dx. This is equal to 1 by root 2 pi integral 0 to 2 pi 1 by root 2 pi integral 0 to 2 pi sine a plus b. A value and b value x is common. Sine a plus b plus sine a minus b. Sine a minus b x dx. Sine a minus b x dx. Now this is equal to 1 by under root 2 pi. Now integration, sine integration, this is sine mx. Sine mx integration minus cos mx by m. So this is cos minus cos 1 by 2 plus n into x by 1 by 2 plus n. Similarly, this one integration minus cos 1 by 2 minus n x by quotient is 1 by 2 minus n. This is between 0 to 2 pi. 0 to 2 pi. Now substitution of limits. Substitution of limits 1 by root 2 pi. First upper limit in one bracket. Upper limit, let me write. First upper limit 2 pi in place of x. In place of x. Okay, and I will take minus common. This minus I will take common here. So both terms becomes plus here inside. So first 2 pi cos this is, if I put 2 pi here. Okay, let me write one more step to understand it very easily. 1 by 2 plus n, and this is plus because minus is common. 1 by 2 minus n into 2 pi by 1 by 2 minus n. This is upper limit. Minus. Coming to lower limit 0. Cos 0 value 1. So this becomes 1 by 1 by 2 plus n plus, because minus is common, this term will be plus. This is also cos 0 1 by 2 minus n. 1 by 2 and this becomes cos, what is this, pi plus 2n pi by 1 by 2 plus n plus. Next value is, this is cos pi minus 2n pi. Pi minus 2n pi 1 by 2 minus n, and this is in one bracket minus 1 by 2 plus n plus 1 by 2 minus n. I'm writing as it is. Now what is cos pi plus theta? Cos pi plus means third quadrant. Cos pi plus theta third quadrant. So 1 by root 2 pi. Cos pi plus theta is minus cos theta. So this becomes minus 2 minus cos 2n pi 1 by 2 plus n. Cos pi minus second quadrant. Second quadrant also cos is negative. So minus cos 2n pi by 1 by 2 minus n. And this is minus. This is 1 by 2 plus n plus 1 by 1 by 2 minus n. 1 by 2 minus n. Next, this is equal to minus 1 by root 2 pi. And what is cos even pi plus 1? Cos 2n pi plus 1. So this is minus 1 by this. And this is also minus 1 by 1 by 2 minus n. And minus 1 by 1 by 2 minus n. And minus 1 by 1 by 2 minus n. So all are same. These two terms same. 1 by 2 plus n. These two terms same and these two terms same. And minus is common. So this becomes 1 by root 2 pi. What is this is? 2 by 1 by 2 plus n plus 2 by 1 by 2 minus n. 2 by 1 by 2 minus n. Okay. Now 2 is common. So that is equal to root 2 by pi. If I take LCM, 1 by 2 minus n here plus 1 by 2 plus n here. And this becomes 1 by 4 minus n square. A plus b into a minus b. 1 by 2 plus n, 1 by 2 minus n. Now this gets cancelled. So this result is under root 2 by pi, 1 by 2 plus 1 by 2. 1. 1 by 1 by 4 minus n square. So I will write this as, take 4 LCM, then 4 root 2 by pi into 1 minus 4n square. Again, I will write this as minus 4 root 2 by pi into 4n square minus 1 I will write. Why I am writing? Because the structure looks simple, like this 4n square minus b can be written as a square a minus b into a plus b, 2n minus 1 into 2n plus 1, 2n minus 1 into 2n plus 1. This is an, this is for all n, and remember here this denominator, in denominator 2n minus 1 is there, and it is an is not defined when n equal to 1 by 2, but n equal to 1 by 2 is not positive integer. Fourier series is defined only for n equal to 0 and n equal to 1, 2, 3 and so on. N equal to 1 by 2 is not positive integer. So there is no need to calculate separately for n equal to 1 by 2. No need at all. Just an value. It is defined for all n which are positive integers. Positive integers. Fourier series is defined for n equal to 0 and all positive integers. Now coming to Bn. Now Bn, what is the formula? Bn 1 over pi integral 0 to 2 pi f of x into sine nx dx. Sine nx dx. This implies Bn equal to, in f of x root 2 is there. This is sine x by 2 sine nx dx. Multiply divided by 2. Multiply divided by 2, 1 by root 2 pi, you will get here 0 to 2 pi. This is 2 sine A sine B. 2 sine A sine B. What is the formula? 2 sine A sine B is equal to 1 by under root, this is 0 to 2 pi. 2 sine A sine B means cos A minus B. A value A minus B. Next, minus cos A plus B, minus A cos A minus B minus cos A plus B. A value x by 2, B value nx, x is common. Now integration 1 by root 2 pi, cosine integration is what? Sine 1 by 2 minus nx over 1 by 2 minus n, and this is minus cosine integration sine 1 by 2 plus n by 1 by 2 plus n x, and this is between 0 to 2 pi. Now substitution of limits. Substitution of limits 1 by root 2 pi big bracket, first upper limit in place of 2 pi sine, here I have to write 2 pi. Take that 2 pi inside. So what is this becomes? This is pi minus 2n pi. Pi minus 2n pi by 1 by 2 minus n minus sine, this is pi plus 2n pi. If I take 2 pi inside, by 1 by 2 plus n. This is upper limit minus. Coming to lower limit, 0. 0 in place of xx, sine 0, 0. So this value 0 minus 0. This entire closed. Entire closed. Now simplification 1 by root 2 pi sine pi minus theta sine theta, so sine 2n pi, sine 2n pi by 1 by 2 minus n. This is also sine pi plus theta minus sine 2n pi by 1 by 2 plus n. Anyway, sine n pi value is what? 0. Sine n pi value 0, so Bn becomes 0. Bn equal to 0 for all n, for all positive integers, for all n positive integers. Now substitute in Fourier series. Therefore Fourier series is f of x equal to a naught. What is the a naught value? 4 root 2 by pi a naught by 2 plus summation n equal to 1 to infinity. And what is a n value? Minus 4 root 2 by pi. A n value minus, I will write here, minus 4 root 2 by pi 2n minus 1 into 2n plus 1 cosine nx. Cosine nx. Okay, this is Fourier series finished. Let me expand this. What is this? Is f of x is nothing but 1 minus cosine x under root. This becomes 4 by 2 root pi minus, let me write constant outsides, 4 by 2 root 4 by 4 into root 2 by pi outside. Okay, and if I expand this, If I expand this by substituting n equal to 1 and so on.
Sir, it's root 2 pi, sir, not 2 root pi.
Yes, sir.
Where? Which
in
one?
the first term, sir. First term in
4 by
RHS.
root 2 pi.
Okay, this is 4 by root 2 pi. Now, if I expand this one, taking this constant outside the summation and expand the summation for n equal to 1, 2, 3 and so on. So the first term will be n equal to 1 cos x by 1 into 3 plus next cos 2x by, if I put 2, this is 3 into 5 plus cos 3x by 3 means 5 into 7 and so on and so on. So what is the required expansion? 1 by 1 into 3, 1 by 3 into 5, 1 by 5 into 7. To get that, put x equal to 0. To get the series expansion, required series expansion, put this one. So what is this is? Left side is what? Cos 0 value 1, 1 minus 1, 0. This is 4 by root 2 pi minus 4 root 2 by pi. Cos 0 value 1, 1 by 1 into 3, 1 by 3 into 5, 1 by 5 into 7 and so on and so on. So let me take this entire minus term to this side. So 4 root 2 by pi into 1 by 1 into 3, 1 by 3 into 5 and so on is equal to what? 4 root 2 pi. So root pi gets cancelled and the result is 1 by 1 into 3, 1 by 3 into 5, 1 by 5 into 7 and so on is what? 4 also gets cancelled, I think, right? Okay, 1 by 2. The value is 1 by 2. Yes, correct. This is one problem based on 0 to 2 pi interval and the function is square root of 1 minus under root cos x. Next one. See, next conditions, I am giving one point here. Functions having points of discontinuity. Functions, or you write like this: Fourier series of a function at a point of discontinuity. See this concept. For example, see, let us consider one interval. Let me take like this x-axis, and this is my y equal to f of x function. If f of x is defined, for example, let me take, this is one point. Take this point A. Take this point, some A, and this is 0. From 0 to A, the function is continuous up to here. I'm taking, say, let f of x be a function. Let f of x be a function defined in the interval c comma c plus 2 pi. Defined in the interval c comma c plus 2 pi, such that it has such that how, let me define this f of x like this. F of x equal to some function, let me consider, okay, phi of x. Consider phi of x from where to where? C less than x less than a. C less than x less than a. And another function, this is phi 1, let me take, and phi 2 of x from where? A less than x less than c plus 2 pi. A less than x less than c plus 2 pi. Okay, so at the point A, what is the function value? I don't know. At A, what is the function value? I don't know. Let me explain graphically. See, somewhere this is c. Let you take c. This is c plus 2 pi. C plus 2 pi, and A is a point in the interval. And in C to A, the curve is what? Curve is given by phi 1x. Assume this is phi 1x. Phi 1x is not equal to phi 2x here. And from A to C plus 2 pi, what is the function? Phi 2x. Since this is phi 1x, curve. phi to x curve, let me assume like this, somewhere up to here. This is phi to x. This is phi to x. That means at this point, at the point A, left limit, clearly limit extends to a minus of f of x not equal to limit extends to a plus f of x. Left limit not equal to right limit. This is called jumped discontinuity. This is called jumped discontinuity. Jumped discontinuity. So function is clearly such that this one clearly f of x is not continuous. Not continuous means discontinuous. F of x is not continuous at x equal to a, because left limit value is phi 1x and right limit value is phi 2x. So it has a discontinuity at x equal to a, at x equal to a. Now when then to converge, for the convergence of the Fourier series, for the convergence of the Fourier series, for the convergence of the Fourier series, the value of f of a is taken as average of left and right limit values, left and right limit values at x equal to a, at x equal to a. That is what is this f of a is taken as? It is taken as limit extends to a minus f of a. Vibration lo pettukondi phones anni. Limit extends to a minus f of x plus limit extends to a plus f of x whole by 2. Nothing but this is phi 1x plus phi 2x. At what point? At x equal to a whole by 2. Phi 1x plus phi 2x whole by 2. This is the f of a. And what is the purpose of taking this discontinuity? Means, for example, see, for example, yeah, in this Fourier series, square root of 1 minus x, and I need expansion of 1 by 1 into 3, 1 by 3 into 5, 1 by 5 into 6. And in this Fourier series expansion, the series is obtained by substituting x equal to 0. When I substitute x equal to 0 in the function f of x, it is defined. What is its value? 0. For example, in some problems, at x equal to 0, this f of x may not be defined. F of x may not be defined at x equal to 0. I will show in the problem. Just assume at x equal to 0, the function is not defined. Then how to evaluate this series expansion? Then at x equal to 0, this function is taken as average of left limit and right limit at x equal to 0. That is the use of this discontinuity. At a point of discontinuity, Fourier series, the function value is taken as average of left and right limit. Okay, this is the first point. And next, another important one, existence of Fourier series. Existence of Fourier series. These are called Dirichlet conditions. These are called Dirichlet conditions. Dirichlet conditions. What are the conditions? First one, you write like this: the Fourier series exists. The Fourier series of f of x exists in the interval of period what? Period must be definitely 2 pi. Remember this, of period 2 pi. If it satisfies the following conditions. Conditions are named as Dirichlet conditions. Following conditions. The first one is f of x is periodic. The function must be periodic function. F of x is periodic function and a single valued function. Single valued function. Single valued and finite function. Single valued and finite function. First condition. And second condition is f of x has a finite number of discontinuities. Has a finite number of discontinuities. F of x has finite number of finite number of finite discontinuities. Finite number of finite discontinuities. Finite number of finite discontinuities. And third one is f of x has finite number of maxima and minima. F of x has finite number of maxima and minima. Finite number of maxima and minima. These are three conditions where Fourier series of a function exists. And remember, if these three conditions satisfy, then Fourier series exists. Definitely Fourier series exists. If one of the condition is not satisfied, Fourier series may exist or may not exist. Remember this point. One of the condition not satisfied, Fourier series may exist or may not exist. That means these conditions are only sufficient conditions. These are only sufficient conditions. For you to get a glance, to get a clear explanation about this, let us consider one problem. The problem is first one, sine 1 by x. F of x equal to sine 1 by x. Let me consider the interval as minus pi to pi. Minus pi to pi. What is this one solution? Sine x. What is this? Is sine x. Its range is what? Minus 1 to plus 1. Its range is what? Minus 1 to plus 1. This is minus pi. I'm taking. This is plus pi. And this is y equal to sine 1 by x. What is its behavior? Sine 1 by x. When x approaches to 0. When x approaches to 0. Through left side or right side. Through left and right sides. That means left limit and right limit. Then sine 1 by x oscillates. Sine 1 by x oscillates between minus 1 and plus 1 infinitely many times. Infinitely many times. Infinitely many times. That means this is 0. When this left limit and right limit is approaches to 0, this is plus 1 and this is minus 1. The curve sine 1 by x, it is oscillates like this. It attains 1 plus 1, 1. This is infinitely many times. Infinitely many times plus 1 and minus 1. This is, I'm taking plus 1 and this is minus 1. That means what? That is sine 1 by x has, what is sine 1 by x range? Minus 1 to plus 1. So minimum value minus 1 and maximum value plus 1. Sine 1 by x attains its maxima and minima. Maxima and minima. What is 1 and minus 1? Infinitely many times. Infinitely many times. Infinitely many times. Therefore, sine 1 by x has no Fourier series. Has no Fourier series. No Fourier series. Another problem. If you want any clear explanation for these oscillations, one can say ask your Google, mother, right? It will give the figure of sine 1 by x. Next one, take another example. Cosecant x, f of x equal to cosecant x in minus pi to pi. Let me take minus pi to pi. Solution is what? F of x equal to cosecant x. Nothing but 1 by sine x, right? Now let me consider sine when this value is not defined at x equal to 0. So which is not defined at x equal to 0. At x equal to 0. That is cosecant x is discontinuous. Cosecant x is discontinuous at x equal to 0. And remember one point, when it has discontinuity, what type of discontinuity it possesses? Because what is the condition? There may be a discontinuity, and what is the type of discontinuity? It must be a finite discontinuity. And such number of finite discontinuity must exist in finite number. See, now what type of discontinuity for this? Let me consider left limit 0 minus f of x. Limit x tends to 0 minus cosecant x. That is limit x tends to 0 minus 1 by sine x. So what is this is when approaches to 0, this is minus infinity, isn't it? One can substitute x equal to 0 minus h tends to 0, then you will get minus infinity, obviously, right? And coming to right limit 0 plus f of x, I'm calculating the type of discontinuity, whether it is infinite or finite, cosecant x. Limit x tends to 0 plus, approaching x through positive values. Here approaching x through negative values, so negative, and this is positive infinity. Therefore, f of x has what type of discontinuity? F of x has infinite discontinuity, not finite discontinuity, as infinite discontinuity at x equal to 0. Therefore, f of x equal to cosecant x has no Fourier series. Okay, this is one model. And let me consider one problem based on type of discontinuity. Yeah, take this. Find the Fourier series of f of x if f of x is equal to minus pi in interval minus pi less than x less than 0, and x in the interval 0 less than x less than pi, and deduce that 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on is equal to pi square by 8. This is one problem. So solution. First you write the Fourier series. Fourier series of f of x in minus pi to pi is, there is no change in the formula, the standard formula. N is 1 to infinity an cos nx plus bn sin nx, equation 1. N is 1 to infinity. Now first quotient, that is a naught, where a naught is what? 1 by pi, and what are the limits? Minus pi to pi f of x dx, and 1 by pi, since this minus pi to pi divided into two parts, minus pi to 0 and 0 to pi. In minus pi to 0, the function value is minus pi. In 0 to pi, function value is x. So let me split this minus pi to pi into two parts, minus pi to 0 f of x dx and 0 to pi f of x dx. Okay, this is the idea when function is defined in two intervals. Next, this equal to 1 by pi minus pi to 0. In the first interval, what is the function value? Minus pi. In the second interval, function value x. So this is equal to 1 by pi. Anyway, this minus pi is the constant. This is x lies between minus pi to 0 plus this is x square by 2 lies between 0 to pi. Right? Now, substitution of limits. Substitution of limits 1 by pi. First minus pi as usual. Now in this one, upper limit 0 minus lower limit in place of x minus pi. First term is over. Upper limit 0 x plus long. Next minus lower limit in place of x minus pi plus. Now this one upper limit, okay, 1 by 2 outside I will take. Upper limit pi square minus 0 you will get. Next step. This is equal to 1 by pi. This is plus pi into minus pi square, and this is plus pi square by 2. And so this is minus 1 by 2 means minus pi square by 2 pi, minus pi square by 2. So this is minus pi by 2. A naught value minus pi by 2. A naught equal to minus pi by 2. And coming to next an. And one more point. Whenever the interval is minus pi to pi, check whether the function is even or odd. First, that is the first point. But since the function is defined in two intervals, and this is minus pi, which is a constant, and this is x, which is variable. So this function is neither even nor odd. That's the first condition. After that only you proceed this Fourier series. Next. Now what is an? An equal to 1 by pi minus pi to pi f of x into cos nx dx. Cos nx dx. So this is equal to 1 by pi. Same logic. This is interval is split into two parts, minus pi to 0 f of x cos nx dx plus 0 to pi f of x cos nx dx. Cos nx dx. Next step. Now substitute the functions. This is equal to 1 by minus pi to 0. What is the function? In the first interval, minus pi cos nx dx, and 0 to pi, this function is x cos nx dx. Next, this is 1 by pi, this minus pi outside, cos nx integration sin nx over n. This is between what limits? Minus pi to 0. And this is, let me write another bracket, derivative part and integrating part. X as usual, cos nx integration sin nx by n minus x derivative is 1. Again, integration of sin minus cos nx by n square. This total between what limit? 0 to pi, and whole bracket closed. Okay. Again, I am using by parts formula, repeated by parts formula. So this is equal to 1 by pi, first one, minus pi. Minus pi, this, let me consider this bracket. And this first upper limit anyway, sin 0, 0. Minus this sin n pi is also 0. So this entire is 0, first one. Coming to second one, plus in the second one, upper limit pi, sin n pi 0, and minus into minus plus, this becomes what? Cos n pi by n square. This is upper limit, minus lower limit 0, in place of this 0 into something 0, minus into minus plus, cos 0 value 1, so 1 by n square. This is over, and this whole bracket closed. Whole bracket closed. Once again, the first term sin 0, 0, sin n pi also 0, so this part 0. Coming to this part, upper limit pi, sin n pi 0, so 0, minus into minus plus, cos n pi by n square. Upper limit is over, minus lower limit 0, 0 into sin 0, and a cos 0 value 1, minus into minus plus 1 by n square. Next step, This is 1 by pi whole bracket. And what is the first term? Completely 0. Plus, what is this? Cos n pi. What is the cos n pi formula? Minus 1 whole power n by n square. Minus 1 by n square. Minus 1 by n square. So, an is equal to 1 by pi n square is common. What is the remaining part? Minus 1 whole power n minus 1. Okay, so I can write this as an is equal to, now this value is 0. When it is 0, if n is even. When n is even, this is plus 1. 1 minus 1, 0. When n is odd, this is minus 1 minus 1. So minus 2 by pi n square if n is odd. If n is odd, this is the value of an. Value of an. And when n even, its value 0. When n is odd, its value minus 2 by pi n square. Now, coming to bn. Now, bn, 1 by pi minus pi to pi, f of x into sine nx dx. F of x into sine nx dx. Now, quickly I will write this directly. In minus pi to 0, the function value minus pi sine nx dx plus 0 to pi, the function value x sine nx dx. Right? Okay. Next one, this is 1 by pi. First one integration minus pi outside constant. Sine integration minus cos nx by n between minus pi to 0. First one is over. Plus, coming to second one by parts. X into sine integration minus cos nx by n minus x derivative 1, again cosine integration sine nx by n square minus term as is. This is between the limits 0 to pi. Okay, now substitution of limits. Substitution of limits. 1 by pi, this minus pi by n as it is, this minus pi and n outside, and upper limit first one. Anyway, this minus into minus plus, I will write plus. Cos 0 1 minus cos n pi, cos of minus theta, cos theta. So cos minus n pi, cos n pi. I will write cos n pi. Okay, this is over. Plus, coming to this upper limit pi minus in place of x pi by n cos n pi. Cos n pi, minus into minus plus sine n pi value 0. Sine n pi value 0. So 0 minus lower limit 0. 0 into 0 and sine 0, 0. So this entire bracket closed. Okay. Now, what is bn becomes now? This equal to 1 by pi. This is, yeah, let me write pi by n minus pi by n cos n pi minus, and this is also minus pi by n cos n pi. Right? So what I'm getting, this is, take pi common. This pi gets cancelled. So 1 by n cos n, 1 by n cos n minus 2 by n cos n pi. 2 by n cos n pi. Isn't it? Right? So I can write this is 1 by n 1 minus 2 cos n pi. Nothing but, so bn is 1 by n 1 minus 2 into cos n pi is what? This is standard formula, okay, in intermediate, cos n pi value minus 1 whole power n. This is bn. Now substitute all the values in 1. Therefore, Fourier series 1 implies, what is f of x equal to, what is a naught value? A naught value, what is a minus pi by 2? A naught value minus pi by 2. Minus pi by 2 into 2, a naught by 2, plus summation. N is defined for what? N equal to even 0 when n is odd. So you write n is odd here. When n is odd, what is its value? It is given by n is odd minus 2 by pi n square minus 2 by pi n square cos nx. And over the summation, you write n equal to odd, or one can write like this: n equal to 1, 3, 5, and so on up to infinity. Okay, plus. Coming to this one, bn sigma, this is n is 1 to infinity, no even, no odd. 1 by n, 1 minus 2 into minus 1 whole power n into sine nx. This is equation 2, Fourier series formula completely. So let me write what is, and I have to deduce something now. What is that? Let me write this clearly. Equation 2, f of x equal to minus pi by 4 and minus 2 by pi, I will write outside, minus 2 by pi outside, constant value. Let me expand summation, n equal to 1 cos x by 1 square, n equal to 3 now, cos 3x by 3 square, n equal to 5, odd, only consider odd terms, 5 square, and so on. This is the about second term. And coming to third one, what is that? Plus, right, n equal to 1. When I put n equal to 1, this is negative, minus plus 3 sin x, 3 sin x, right? And n equal to 2, if I consider 1 minus 2, minus 1. So minus sine 2x by 2, sine 2x by 2. When n equal to 3, that is negative again, 3 sine 3x by 3, 3 sine 3x by 3, and so on, and so on. This is Fourier series expansion. This is Fourier series expansion. Take this as 2 or, okay, 3. Let me take 3. And I need what expansion? I need expansion 1 by 1 square plus 1 by 3 square plus 1 by 5 square. So to get this expansion 1 by 1 square, 1 by 3 square, I have to substitute 0, x equal to 0. So put x equal to 0 in 3, in equation 3. Okay. So 3 implies, therefore 3 implies, this is f of 0 left side, minus pi by 4, minus 2 by pi. This is 1 by 1 square, 1 by 3 square, 1 by 5 square, and so on. And what is this sine 0? Everything 0. Everything 0. Okay, take this as 4. But what is f of 0? But what is f of 0? Right? See the function. What is my function? Original function is what? The question, yeah. This is less than 0 only. This is greater than 0 only. So at x equal to 0, the function is not given. Okay. Clearly, you write like this. By the definition, by the given function, f of 0 is not defined. F of 0 is not defined. That is, f of x is discontinuous at x equal to 0. Then how to consider? Then consider f of 0 as what? Left limit 0 minus of f of x, and a right limit 0 plus of f of x, average by 2. What is left? What is the function is given as? F of x is minus pi in minus pi less than x less than 0 equal to x 0 less than x less than pi. This is the function. So when x less than 0, left limit, when x less than 0, what is the function value? Minus pi. This implies f of 0 is, this is, take this as 5. 5 implies this is what? Minus pi at x equal to 0. What is the right limit? When x is greater than 0, x tends to 0 plus means greater than 0, its value is x at x equal to 0 by 2. So this is, remember, I have to evaluate at x equal to 0. That's important. Take the limit values, then put x equal to 0. So minus pi plus 0 by 2, the value is minus pi by 2. Value is minus, f of 0 value is minus pi by 2. Therefore, what is this expansion? What is this? 4 expansion. Equation 4 implies minus pi by 2 equal to, what is this? Minus pi by 4. Minus pi by 4. Next one, minus 2 by pi. Minus 2 by pi. 1 by 1 square, 1 by 3 square, 1 by 5 square, and so on. And so on. So this is equal to 2 by pi, 1 by 1 square, 1 by 3 square, and so on, equal to minus pi by 4 plus pi by 2. So what is this value? 4. Minus pi plus 2 pi. Pi by 4. Pi by 4. This implies 1 by 1 square plus 1 by 3 square plus 1 by 5 square and so on, equal to what? Pi by 4 into 2 by pi. Pi square by 8. Yes?
Minus pi by 4.
Huh? Minus pi by 4. This is 4 LCM. This is minus pi and this is 2 pi. Plus pi by 4, correct?
Yes, sir.
Okay. So this is the deduction. Is that clear? Okay. Now class is open for doubts.
Sir, in yesterday's question I have doubt, sir. Assignment.
You ask afterwards. In the afternoon session, you will ask. Okay.
Okay, sir.
Yesterday's question, which one?
Third one, sir.
What is the problem? Third one?
Sir, third one, 1 minute, sir. You gave 1 by 1 square plus 1 by 2 square, sir. I got in the form of 1 by